So here we go with the first of the two videos that I would like you to watch today and take notes on. On this first warm-up, I'll go through it. Then later on both of these videos, I'm going to have you going through and pausing the video, doing the problem, and then hitting play back on the video and watching, make sure that you're doing it right. But for this first one, as a warm-up, we need to find first the domain, the vertical asymptotes, and then use logic to describe asymptote behavior and end behavior. Okay? So 4 things that we need in this classic type problem. Okay? So the first thing is we need to find the domain. Okay? So if I am finding the domain, I'm taking my denominator, which is x minus 3, and I'm setting it equal to 0. Because the domain is going to be all real numbers except where that denominator is equal to 0. So if I quick solve this, I get x equals 3. Okay? So my first answer, my first part, the domain of this function is all real numbers, but x cannot be 3. And that's how I would write that. We learned that yesterday. Actually, excuse me, we learned that Monday. Forgot, we don't have class on Tuesday. Okay? Second thing, then we need to find vertical asymptotes. Well, the vertical asymptotes are just where we have points of discontinuity or where we have zeros in our denominator. So the second part of the answer we've already done. The second part, the vertical asymptotes, would be at x equals 3. Later on this week, meaning tomorrow, we're going to be graphing these functions. And so that would be a vertical line dashed on our graph because we can't cross over. The function can't cross over that. Okay? So we did both of those two together, okay? Which is why it's the first step. Okay? Now we have to use logic to describe the asymptote behavior, what the function's doing at the asymptote. So that's going to be on either side of 3. Okay? So my third one is asymptote behavior. So I'm going to have as x approaches 3 from the left, what is my function doing? And I'm going to have as x approaches 3 from the right, what is my function doing? Okay? So if I'm thinking about 3 on a number line, okay? So I've got 3 here on my number line. As I approach from the left, okay, that means I would have numbers just a little bit smaller than 3. So for instance, like a 2.9. Okay? If I plug 2.9 into my function, then I get negative 1 over 2.9 minus 3. Well, that's going to be negative 1 over negative 0.1. Negative divided by a negative is going to be positive, and this number right here, that number, the closer and closer I get to 3 from the left, that number down there is going to get smaller and smaller and smaller, always going to be negative, so that's going to go to positive infinity, because a negative divided by a negative is positive. Now as I come in from the right towards 3, now that's going to be like 3.1. I plug that into my function, and my function is going to say, well, that's going to be negative 1 divided by 3.1 minus 3, which is going to be negative 1 divided by positive 0.1. And again, the closer and closer I get from the right side to 3, the smaller and smaller that number is going to be getting. But a negative divided by a positive is going to be negative infinity. And then the last one that we have is our end behavior. That's been what we were doing in the last, in unit 3. So that's going to be as x now goes to positive infinity, what is my function doing? And as x is going to negative infinity, what is my function doing? Okay. So here we could pick a really, really, really large number, like let's say 1,000,000, positive 1,000,000. If I plug that into my function, I'm going to have negative 1 over 1,000,000 minus 3, which is 999,997. And that's going to be a super small number, but it's going to be negative. So we're going to say then that f of x here is approaching 0 from below, because it's on the negative side, and we can't have negative 0. So we're approaching it from below. Now let's flip that around, and let's say we're going to go to negative 1,000,000. Now we would have negative 1 over negative 1,000,000 minus 3 is going to be negative 1,000,003, which negative divided by a negative is going to be a positive super small number. So that's going to approach 0 from above. And those, ladies and gentlemen, are the 4 answers that we were looking for when the problem started. The domain is all real numbers, but x can't be 3. The vertical asymptote is x equals 3. The asymptotal behavior as x approaches negative 3, f of x is shooting up. It's going to positive infinity. As it approaches 3 from the right side, it's shooting down. It's going to negative infinity. On the right side of my graph, the function is approaching 0 from the bottom, and the left side is approaching 0 from above. That's what that's all saying. We're basically graphing here without actually graphing. So what I want you to do on this one is, 1, make sure we're reading directions. So on this particular one, it says just find the domain and the vertical asymptotes. Okay? So I want you to pause the video now, do that, and then come back to the video and push play and see what the answers are. So if we need to find the domain and the vertical asymptotes, we would set our denominator. We would set that equal to 0. Now, we could factor this perfect square minus a perfect square. Then set the factors equal to 0. That works in this case. Or we could have said x squared minus 9 equals 0. We could have added 9 to both sides, taken the square root on both sides. But with that comes the fact that we've got to remember we took the square root. I need the plus or minus in there because I've got to have 2 answers. So there's our points of discontinuity. So the domain of this function would be all real numbers, but x cannot equal plus or minus 3, positive or negative 3. If you wrote this out as all real numbers, but x cannot equal negative 3, x cannot equal positive 3, that's fine too. Either one of those works. But then here now, in the second part, in my vertical asymptotes, where now you're telling me the equations of the lines, here now they definitely need to be separated. You can't just go with this. Don't do that. They have to be separated out because they are two different lines. Okay? And so there is the answers to the two questions we were asked. Here is another problem. This is the last example from video number 1. So do this problem and then come back and, so pause the video and then come back and see the answers. So first we got to set our denominator equal to 0 to find our discontinuities in the domain. We got discontinuities at both plus and minus 5. So the domain here would be all real numbers, but x cannot equal both positive and negative 5. Which then that can take me right into my vertical asymptotes. X is going to equal 5, and x is going to equal negative 5. All just from that one. Now, because I have 2 vertical asymptotes, that means then that I need to have 4 sets of asymptotal behavior. So as x is approaching negative 5 from the left, g of x is doing something. As x is approaching negative 5 from the right, what's g of x doing? Then I got to go to positive 5. As x is approaching 5 from the left, what is g of x doing? And as x is approaching positive 5 from the right, what is g of x doing? Well, now let's figure that out. Oops, jumped on me. So if I'm looking here at negative 5, so left side, green on the other side, so left side, so this would be negative 5 from the left, my very first one. So that would be like negative 5.1. So if I plug that in, I've got negative 5.1 all over negative 5.1 squared, which is 26.01 minus 25. So that's going to be negative 5.1 over 1.01. Now, I'm not so much worried about what it's going to do because I know it's going to go to an infinity, because this bottom number here, the closer and closer I get, is going to get closer and closer and closer to 25. So that number is going to get smaller and smaller and smaller. I was more looking for the positivity, and I've got a negative here divided by a positive number, so that's going to be negative infinity. On the other side, now it's going to be like negative 4.9, and that's going to be negative 4.9 divided by negative 4.9 squared is 24.01 minus 25. So now I've got negative 4.9 divided by negative 0.99. Negative divided by a negative here, because again, this number right here, just like that number right there, is going to get closer and closer and closer to 25, which means this number is going to get smaller and smaller and always being negative, negative divided by a negative, this one's going to go to positive infinity. Then I come over here now to positive 5, and I've got to do the exact same thing again. Now, I can use the exact same numbers, except they're going to change a little bit here. Now, first I'm going to use 4.9. Oops. Okay. So 4.9 divided by 24.01 minus 25, because it's squared, it's all going to be the same. That's going to be positive 4.9 divided by positive now, divided by negative still, that. Again, this number here is going to get closer and closer to 25, which means this number here is going to get smaller and smaller and smaller, which means positive divided by a negative would be negative infinity. And then lastly, we're going to come in here on this side, and that's going to be like 5.1 divided by 26.01. It's the green one, minus 25. So now we've got a positive 5.1 divided by a positive, going to be even smaller and smaller and smaller number. Positive divided by a positive is going to be positive. And then lastly, we've got our end behavior as x is going to positive infinity. What's our function going to do? And as x approaches negative infinity, what is our function going to do? Our function again was g of x is equal to x over x squared minus 25. So if I put in a really, 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 really big number, 1 million. So then that's going to be a positive big number, positive 1 million on the top. 1 million squared is going to be one with ginormous, 12 zeros after it, minus 25. That's going to be a positive number, but it's going to be a huge number. So that's going to go to 0 from above because both are positive. Now, if I flip that over and I say, let's go negative 1 million here, one more 0. Now I'm going to have a negative number over a positive huge number because a negative squared is positive. So it's going to be 1, positive 1 with 12 zeros behind it. Then I subtract 25. Still going to be a positive huge number. Negative divided by a positive huge number is going to go to 0. Because the farther and farther I get away from the middle of the graph, those numbers are just going to get bigger and bigger and bigger. It's going to be negative. And that concludes video number 1. You now can do number 2 on this week's worksheet just based off of this video.